Hello, welcome to the sixth lesson of this chapter. Today we're going to do some word problems using the trigonometry that we've just learned. First problem, a weight attached to the end of a long spring is bouncing up and down. As it bounces, its height above the ground varies sinusoidally with time. At 0.3 seconds after starting a stopwatch, the weight first reaches its highest point, 60 centimeters above the floor. At 1.8 seconds, it first reaches a low point at 40 centimeters above the floor. Sketch a graph of the height of the weight above the floor as a function of time. I think I could have probably not had two ofs in there, but so we want to know the height that the weight is at above the floor as a function of time. So this is going to be our time. This is going to be our height. And at 0.3 seconds, we know it is 60 centimeters. So 10, 20, 30, 40, 50, 60. So that's its high point. So let's draw on its upper bound. And at 1.8 seconds, it's 40. So 40 is its lower bound right here. So that's at 1.8 seconds. Let's just say that's out here. So we have a high point, we have a low point, and if it goes sinusoidally, it'll look like this. Now this distance is 1.5, which is not the period, because 1.5 is just enough to do half of it. So what we need to do is finish the other half, another 1.5 away, which would be at 3.3. All right, so now we have one entire graph of, or one cycle of this equation. So if I wanted to find the equation of this, the sinusoidal axis is right in the middle at 50. It goes up 10 and down 10, so that will be 10. And this will be cosine, because we have a height. Now we move this to the right 0.3, and now we just need a dilation factor. Now we know that it does a whole cycle in 1.5 plus 1.5, which is 3. And cosine does a whole cycle normally at 2 pi. So if we take 2 pi and divide it by 3, that's going to be what we put after our cosine. All right, so we have our equation. If we want to find out the height when the stopwatch reads 7.2 seconds, what we do is bring up our trusty calculator, and we graph in our y equals 50 plus 10 cosine 2 pi over 3 times x minus 0.3. Now, pay attention to these parentheses. Now, everything after the cosine has to be in a parenthesis. So there's a parenthesis here, and that ends at the end. And then there's another set of parentheses around the x minus 0.3. Now, we don't need the second equation yet. I prepared this in advance. So now we have to look at what our problem is saying. It says, when is it at 7.2 seconds? So that's when our y is 7.2. So let's go to our table. Let's start our table at 17.2 and press second graph. At 17.2 seconds, it's at 43.309. Great. So that's going to be the height when the stopwatch is at 17.2 seconds. What is the height when the height of the weight when the stopwatch was started? So that's at 0 seconds. So what we can do is go back and press 0 and second table, and you can see that at 58.9 I should say, that was the height of the spring when it started. What is the first positive value of the time where the weight is 55 centimeters above the floor? So that's when the y is 55. So we go back in here, and when the y is 55, we press graph. Now your graph probably won't look identical to this because your window will probably be a little bit off, a little bit different than mine. but I chose from 0 to 5 for the x values and 0 to 60 for the y values. And the reason I did that is because on my graph, I went up to 60, and this does one graph by the time it gets to 3.3, so I just did a little bit further to get to 5. All right, so our problem said it wanted the first time positive value that it was 55. So the first positive time it's about at 55 is that intersection right there. So to figure that out, I press second trace. 5 is my intersect. And it says first curve, you hit enter. Second curve, you hit enter. And now you go as close as you can to our point and hit enter. And our intersection is at 0.855. So at x equals 0.8, that's the first time that the weight is going to be at 55 centimeters above the floor. All right, so we got that done. Now let's do this part F where it says show algebraically how we can find the answer. All right, so we have 55 as our answer, and we have to put in our equation. 50 plus 10 cosine 2 pi over 3 x minus 0.3. All right, now our first step is to subtract 50 from both sides. And 55 minus 50 is 5. Then I have 10 cosine 2 pi over 3 x minus 0.3. Now we divide by 10. So if I divide by 10, I'm going to get 1/2 is equal to cosine 2 pi over 3 x minus 0.3. So now what I need to do is take the arc cosine of both sides. That's supposed to be a c of 1/2. Arc cosine of cosine cancels out, so I'll have 2 pi over 3 x minus 0.3. Arc cosine of 1/2 is plus or minus inverse cosine of 1/2 plus 2 pi n. Remember the arc cosine, we can convert this to this formula. That's what we learned on our previous day. Inverse cosine of 1/2, cosine ranges from 0 to pi. 1/2 occurs when the adjacent side is 1, the hypotenuse is 2. That's when it's 60 degrees. So to do 60, that's dividing that into 3. And so that's got to be pi over 3. So this is plus or minus pi over 3 plus 2 pi n. That equals 2 pi over 3 x minus 0.3. Now our next step is to get rid of 2 pi over 3. To do that, we multiply both sides by 3 over 2 pi. That will cancel those out and those out. So I have to multiply this side 3 over 2 pi, and we do that to both sections. So 3 times pi is 3 pi. 2 pi times 3 is going to be 6 pi. And then 3 times 2 pi would be 6 pi. This is like over 1, so 2 pi times 1 is just 2 pi. I forgot to change my colors back, so now I'm back to blue. I'll switch it to red. All right, now let's simplify this. This is going to be plus or minus. 3 over 6 is 1/2. The pi's will cancel out. 6 over 2, that would be 3n equals x minus 0.3. So now what we do is we add 0.3 to both sides. And you could keep this in decimal form, or you could do it in fractions. But I think decimal might be easy because everyone knows this is 0.5. 0.5 plus 3 is 0.8. And negative 1/2, so negative 0.5 plus 3 is going to be negative 0.2 plus 3n. All right, those are my two equations for all of the values of x. All right, we have another equation. On a vacation, or another problem. On a vacation in Maine, you notice a seawall that has markings to show the depth of the water in the ocean. At 7 a.m., the water is at low tide at a height of 10 meters. At 1 p.m., you see the water reach its highest depth at 24 meters. Sketch a graph of the depth of the ocean as a function of time, mark the scales on your axis, and draw at least one full cycle of the ocean's depth. So time is kind of a tough one because where do we start? Probably a good idea is to start at midnight, and then this would be 1, 2, 3, 4, 5, 6, 7. So this is 7 a.m., and at 7 a.m., it's 10 high. So maybe let's just do this by 5, 5, 10, 15, 20, 25. At 7 a.m., it's 10 high. So we do 8, 9, 10, 11, 12, 1. So we can say this is 1 p.m. Maybe it'd be good to just use military time and say this is 13. And at that point, it's at 24, so a little below our 25. It always helps to draw these lines out. Makes me a little bit more honest. And so we have a low, we have a high, so it looks like this. So we can continue it back. And from 7 to 13, that's 6. So it's going to hit its peak here again at 1 in the morning. So let's look at, so that's the graph. Let's try to find the equation. Y equals the middle of 10 and 24. Well, we add them together, divide by 2. 10 plus 24 is 34, divide by 2. That's 17. We go up and down 7 for our amplitude. Cosine of, well, we move to the right one, so that's x minus 1. Now we need to figure out what our dilation factor is. It does a full cycle between 1 a.m. and 13 or 1 p.m. So that's 12. So 2 pi over 12 is just pi over 6. All right. So if I want to use the equation to find the depth of the ocean at 3 p.m., notice we have to look at a.m. and p.m. p.m. would just be 2 over this way, so 3. I would write this as 15. So we need to put 15 in the equation. So if we put 15 in for x, we can find our y value. I'll type this into my... All right, I have the equation in my calculator. And what I want to do is try to figure out a window that would work. And so I'll go from 0 to, say, 15 in my x, because that's what it looks like on this axis. And my y, I'll go from 0 to 25. And if I graph it, it should look something similar to the graph that I have on my paper or my whiteboard. So if I want to find out at 3, all I have to do is put in 15 for my table. And at 15, it's 20.5. What's the first time after noon when the depth was 15 meters? So if I go to my y equals 15 meters, that's a y value. So now if I graph that, first time after noon. So noon is at 12. So our x value, if I trace, it looks like it hits there once at when the time is 9.4, so over 9 hours. But after noon, we'll have to keep going. So let's extend the window to maybe 20. So if that was too, this data point was too small, what we'll need to do is find this data point. So second trace, intersect, which is number 5, enter, enter, and then our guess, we just move this over. And it's at 16.5. So 1630, which would be about 4:30 at night. All right, so we have that figured out. Ooh, and your homework is right here from 3.7. Good luck.